Okay, Mike, and good morning, everyone. Today we'll be discussing about transportation of carbon dioxide in blood, which occurs in three forms. Okay, so first, 70% of carbon dioxide in blood they are transported through the plasma or blood plasma. Okay, as bicarbonate ions. Okay, now this is the tissues of an active respiring cells. Okay, turn on the highlighter. Okay, so first things here, the carbon dioxide from these active respiring cells will diffuses into the red blood cell. Okay, and this carbon dioxide will combine with water. Okay, to form, you can see here, this carbon dioxide combined with the water to form carbonic acid, and this reaction is catalyzed by carbonic anhydrase. Okay, and next, this carbonic acid, they are unstable compound. Okay, thus this carbonic acid quickly dissociates or ionizes into hydrogen ions and hydrogen carbonate ions or bicarbonates. Okay, these bicarbonates will diffuses into the blood plasma, which then transported to the lungs by the blood circulatory system. Okay, now, what happens immediately after the hydrogen bicarbonate ions diffuses into the blood plasma from the red blood cell? Okay, chloride shift occurs. Okay, chloride ions from the blood plasma will diffuses into the red blood cells. You can see from here. Okay, the purpose is to balance the changes of charges when bicarbonate ions diffuses out from the red blood cell. Okay, bicarbonate ions are negative charges. The same goes for the chloride ions. So they are imbalance of charges inside the red blood cell because the hydrogen ions earlier, remember, from the ionization or dissociation of the carbonic acid is still inside the red blood cell, and this is the positive charges or anion. Okay, sorry, cation. Okay, so the total net charges here needs to be balanced up. That's why chloride shift occurs. Okay, or simply this chloride shift occurs to maintain the electronegativity of the red blood cell. Okay, after the diffusion of hydrogen carbonate ions into the blood plasma from the red blood cell. The hemoglobin, inside the red blood cell, unable to maintain its full bound oxygen carrying capacity in the presence of low or lower oxygen partial pressure. Okay, so what happened? The oxyhemoglobin will unloads its oxygen, and the hemoglobin, this hemoglobin will combine with the hydrogen ions to form hemoglobinic acid, HHB. Okay, now take note that a part of 70% of carbon dioxide transported in blood as bicarbonate ions, which is this one here. Okay, there are 23% of carbon dioxide that enters the red blood cell will directly combine with the hemoglobin to form carbaminohemoglobin. Okay, so this is the first and third means of transportation of carbon dioxide in blood. Okay, now the other one is 7%. Okay, 7% of carbon dioxide, they just simply dissolves into the blood plasma and transported by the blood plasma. Okay, now just now I mentioned that 23% of carbon dioxide that enters the red blood cell combined with hemoglobin to form carbaminohemoglobin. Okay, now what happens? Apparently carbon dioxide that combined with the hemoglobin, the carbon dioxide will bind with the N terminus of the hemoglobin polypeptide chains. Okay, now this compound is quite stable, okay, and it only sorry, the carbaminohemoglobin only dissociates, okay, or releases or unloads the carbon dioxide, okay, when there is low partial pressure of carbon dioxide. Remember, in active respiring tissues, the partial pressure of carbon dioxide is relatively high, okay, and this carbaminohemoglobin, okay, as well as the hydrogen carbonate ions in the blood plasma, okay, and the carbon dioxide that simply diffuse into the blood plasma, okay, will be transported all the way to the lungs, okay. Now in the lungs, the carbon dioxide partial pressure is low, right, because lungs is the place where the gases exchange of oxygen and carbon dioxide occurs. You know that already. So now the low partial pressure, the low partial pressure of carbon dioxide, okay, and the alveoli that is very low will stimulates the carbon dioxide, okay, to diffuses out from the red blood cell into the alveoli for gases exchange. Okay, now the hydrogen carbonate ions that dissolve into the blood plasma, remember, okay, now these hydrogen carbonate ions will diffuse into the red blood cell first. Okay, when it diffuses into the red blood cell, what happens? The reverse process of earlier that I have discussed with you will occurs, okay, where finally carbon dioxide will be formed inside the red blood cell, and that carbon dioxide will diffuses out from the red blood cell to the alveoli. The lesser oxygen carried by the hemoglobin, the more carbon dioxide will bind with the hemoglobin. Okay, so that's it today, okay, for the transportation of carbon dioxide in blood. Okay, thank you for watching and happy learning.